The last lecture in section 2 talks about the two different types of logarithms. And again, this should be a review for you, but we'll still cover it. First one is a common log. We call it common because we're going to use base 10. It's very common because our number system is in base 10. So that just means that the base on the log is 10. So if I give a problem like this, I'm actually going to, because we use it so often, not write the base. So I'm asking, what is the exponent on 10 such I get 100? So this is saying, what is the exponent on the base, which happens to be 10 because it's not showing, that gives me 100. So my answer to that is 2. So in this situation where I have log 1, it's saying, what is the exponent on base 10 such that I get 1? What is the exponent on base 10 such that I get 1? That answer would be 0. In this case, it's saying, what is the exponent on base 10 such that I get e? If you remember or recall, e is that number 2.71828 that occurs, and it goes on, that occurs naturally. So we can't really simplify that without a calculator. Let's see, 10 to what power is 2? Well, 10 to the first is 10. 10 to the 0 is 1, so it looks like it's some decimal fairly close to 0. We do want to know this, so we need to have a second logarithm, and that's called a natural log. And a natural log has base e. So we're only going to work typically with these two, and we spend a lot of time in calculus with them. We do not write log base e. We use it so often, we're just going to write natural log. And if you look on your calculator, you'll see that those two are in yellow and in white, meaning they undo each other. So in this situation, this is saying, what is the exponent on base e such that I get 1? Well, the answer to that is 0. This is asking, what is the exponent on base e such that I get e? Well, that answer is 1. E to the first is e. So properties of natural logs, well, they're no different than properties of common logs. In other words, natural log of 1 is 0. E to the 0 equals 1. The natural log of e is 1. In other words, e to the first power is e. Remember that base is e to the first and gives me that value. The natural log of e to the x is equal to x. In other words, when I look at this piece right here, it's saying, what is the exponent on e such that I get e to the x? Well, if these two are going to match, then whatever I'm looking for has to be equal to that x. And e to the natural log of x is equal to x. E and natural log are inverses of each other. They undo each other, so you get that x. E and natural log undo each other. Common log and base 10 undo each other. So what does a graph of a natural log look like? Well, if we graph a common, we just know that that has base 10. So if I graph something with base 10, I still have the start value, and I'm going to graph the exponential, so it's pretty steep. And if I go and graph the natural log, which has base e, and if you recall yesterday we did that graph, exponential graph of that, with an e as the base, we know that it follows this, but it's not near as steep. So if I'm looking for the inverse or graphing the log of these, all I need to do is reflect it about this line. So they both are going to pass through this point. So reflecting the blue seems to spread out more, okay, be a little bit flatter, so it's going to look similar to this. Okay, it's not going to be as steep. And since that blue is, I should probably use the blue in color because the blue is e to the x. When I do that, let's see, it's going to come closer to that line. So it's going to be a little bit raised up where the base 10 is going to come in and flatten out more. And just recall that that is that reflection, the inverse about the line y equals x.